Hello guys, welcome back. In this video, I'm going to talk about finding drawing a scale. This is based on the feedback that I received from you from lab 1. So some of the students, they asked me about drawing a scale. Just imagine that this is an engineering drawing and this is a finished drawing, and you can see different views here, probably with different scales. And here we have some text. I just need to go back a little bit and talk about paper standard, that we had this before, and you can go back and watch the video that I prepared for paper standard. So we have two different standards, ISO and ANSI, based on the country that you are live in. So if you're living in any country, most of the countries except North America, your paper size probably is ISO. And the most popular paper size is this one, A0. And we said that if you fold A0 to half, it's going to be A1, another fold A2, A3, A4. For those of you who are international students, you deal with A4 paper size. You use A4 paper size. In North America, the standard is a little bit different. We said that the paper that we use for, let's say, architectural drawings is 34 by 44 inches. And we call it E size. Half of E size drawing, half of E size sheet, we call it D. Half of D we call it C. Half of C we call it B. And half of B we call it A, which is 8.5 by 11. We call it, another name is letter size. And 2 times of A we call it B, which is the tabloid size. So in this video, I mainly focus on these type of sheets. So when we talk, for example, about D size sheet, we are talking about a sheet which the size is 22 by 34. How to print the drawing? We said this before, that we're going to use a plotter for size of E, D, and C. For smaller sizes like A and B, use regular printers. And this is a drawing result. This is a drawing sheet. There's a letter usually here, and that letter indicates the size of the sheet. For example, in this case, the size is A1. So it means that this is an ISO standard drawing. A1 is basically half of A0, is 594 millimeter by 841 millimeter. If you want to compare A1 to ANSI standard, is almost the same size as D. Not exactly, but it's close to D. So this is almost a D size drawing. Okay. So we have some text on the drawing. We have some dimensions on the drawing. And we want to be able to read the text and dimensions when you look at the drawing. Now the question is that, what text size I can have on a drawing? What text size is a good text size? Depends on the company that you work for. Okay, so the text size usually goes from here to here. from 332, which is half of 316, which sits here, and 18, and sometimes 316. In our class, usually we go with around 316, which is about 0.20 inches. Or if you convert it to millimeter, it's around 5 millimeter. It's 4.75 millimeter. It's around 5 millimeter. So this is the text size that we use on our engineering drawings. And this is almost the dimension size that we use for our engineering drawing. These two may change, as I said, depending on the company that you are work for or your personal preferences. You may change height of the text for dimension, height of the text for the text, the notes that you have here. Okay, so another thing that I want to talk about here is engineering drawing scale. If you're working as a mechanical engineer, if you want to make a drawing of, let's say, a part like this, this is the actual part. When you want to put it on the drawing, you scale it. If the part is small, you scale it up. If the part is large, you scale it down. In this case here, we are scaling it down to fit it on our drawing sheet. So we just scale this one down and put it here. So the scale that we are using here is 1:2. So basically this is 2 times of this one, or this is half of this one. So 1:2, 1 divided by 2 is half. So half of this becomes this. We call it a scale factor. So 0.5 here is the scale factor. So now think of this. This is from your lab 3. Later on we're going to work on this one. This is the view that I have, and I prepared this one in AutoCAD. Now I want to transfer this one on a sheet. The sheet that I want to use here is a D-size sheet. If I put the view on a D-size sheet, after plotting, you will see that the dimensions, the text, everything is readable. But imagine that I scale everything down to fit it on a A-size sheet, which is 8.5 by 11. So this is way smaller than this one. It's like 8 times smaller than this one. So this A-size sheet, if I put the view on A-size sheet, you will see that the text and dimensions, they're not readable. And the reason is that AutoCAD has been designed the way that the lines, objects, whatever you have here, and text and dimensions, hatches, everything is almost the same. So when you scale down the lines, when you scale down the circles, it's going to scale down size of your text too. So as a result, if height of your text was 0.2 inches and you scale down everything 100 times down, or in this case, for example, here 8 times down, that text size is going to be very, very small. Okay? So that's something that we have to deal with, and this is from AutoCAD. If you use other engineering software, like let's say CATIA, we don't have such a problem with CATIA because the environment that you make the drawing is different than environment that you design. So basically this text size here on the drawing is fixed. Look at here, you have a large view and you have a detailed view here, and for both of them the text height is the same. Another software that we usually use in engineering, mechanical engineering, is SolidWorks. So the same product from Dassault system. So they solve the problem in their products. But look at the price here. If you're using CATIA, you have to pay around $65,000 per seat. If you're using SolidWorks, you have to pay $11,000 per seat. But for AutoCAD, you just pay $2,000 per year. Okay, so that's the difference. You may think that, okay, I'm going to pay more. I'm going to go, for example, with SolidWorks. The problem is that in this industry, in, let's say, civil industry, civil engineering industry, architectural industry, fire industry, even if you go with other software, you will see that your partners, they're using AutoCAD. So automatically you have to switch to AutoCAD. It doesn't mean that AutoCAD is bad. AutoCAD has been designed for this kind of jobs. Okay, so we have lots of other features in AutoCAD that those software, they don't have it. But this is the problem that we have, and we want to find a solution for this one. Again, we want to make sure that when we change the scale, the text size stay the same. So the text be readable. Let's say you want to put this layout, this plan view, on a size sheet, and you just want to have overall dimension of the building. So for that reason, you don't want to plot a D size sheet. You prefer to go with a small size sheet. So you just want to change the text size, the height of the text for dimension or text that notes that you may have on the drawing, just for that one. Okay. So the problem is AutoCAD. Okay, so as I said, in AutoCAD, we just have this problem. And we call those objects that their dimension change by the scale, or they are sensitive to a scale. We call them annotative objects. What are those? They are texts, blocks, hatches, dimensions, geometric tolerances, and multi-leaders and multi-leader styles. So far, we just know about texts, blocks, and dimensions. And maybe you tried hatches by yourself. For example, if you change the scale of a drawing, you will see the effect on text or dimension. Okay, I have to stop the video at this point. In my next video, I'm going to continue with this subject. Talk to you soon.